In this example, we're told a geyser has a mean time between eruptions of 89 minutes, and let the interval of time eruptions be normally distributed with a standard deviation of 19 minutes. And then we have several parts here that we're going to complete. This first one asks for the probability a randomly selected time interval between eruptions is longer than 97 minutes. So here I can go to second vars, normal CDF. My lower bound is 97. Let's set the upper at the highest, 1E99. The mean, 89, and the standard deviation, 19. And that's how we arrive at this 0.3369. The next question's a little bit different because we're looking at random samples of size 13. All right, so the difference here, notice that everything else, though, is the same. The difference that we do in our calculator is we're going to use this statement from our text. The mean of the sampling distribution of the means, or X bar, is the same. But the standard deviation is the population standard deviation divided by the square root of the sample size. So here's where the difference comes in. This is the step that's a little bit different. So I go back to normal CDF. Everything else stays the same until this part where I must divide by the square root of the sample size. And then I need that to 4 decimal places. So that's that 0.0645. In part C, the difference here, everything else is similar over here, but the difference is the size of the random sample is now 30. So when I turn to my calculator, what I will do differently for normal CDF is I will change that sample size to 30. And here is that probability. The probability that the mean of the random sample of 30 time intervals is more than 97 minutes. In the next part, we're asked to determine an effect. What effect does increasing the sample size have on the probabilities? So that was the nice thing about keeping everything else constant in parts B and C other than the sample size, is we can now determine that effect. We'll fill in these blanks below. So if the population mean is less than 97 minutes, the probability that the sample mean of the time between eruptions is greater than 97 minutes decreases because the variability in the sample mean decreases as the sample size increases. And again, I just want to point out that that comes from one of those videos. I took this screenshot from one of the videos in section 8.1 interactive assignment that talks about that change in the standard deviation here. In the last part of this problem, we're asked to interpret the results of that probability we obtained with the sample size of 30. So I'm just going to scroll back up real quick. Remember, that was a very low probability, like about 1%, 0.01. So what does that mean? It could mean that the population mean may be greater than 89, because this is a very unlikely result. I can't say that it must be more than 89. Remember, probability statements are very rarely definitive statements like that. Or it could still be that the population mean is 89 and this is just a rare sample. And just for clarification, I'm picking the greater than or more statements here, or leaning towards those, because remember, in that sample we were looking for the mean to be more than 97, and the chance of that happening was just really low.